Okay, and you converted it into an equivalent decimal number. So I give you
Decimal.
more examples. Suppose I give you 1f.01b. It's okay. So this is a decimal number. You convert it into a decimal number. So do this. So f is 15 and b is how much?
12.
12. Okay. Then 16 raised to 0, 16 raised to 1. You multiply. This is 16 raised to minus 1, minus 2, minus 3. Then add all. Today lots of problem
Oh,
we
B
will.
is 13.
Huh?
B is 13.
B is 30. Okay, B is 11 and F is 50.
11.
Yeah, because 0 to 9 and then 10 से start होता है ना, तो A is 10, B is 11, C is 12 and that's why F is 15.
Okay, okay. Yeah. So,
Hexadecimal, no? 0 to 9 and then A, B, C, D.
Yeah.
So B is, you have to remember this. That's why I gave you this example. So B is 11, F is 15. Okay, so when I convert 16 raised to 0, 16 raised to 1 and the coefficient are 1 and 15 for 1 and F. Then we have, oh, okay, 0 into 16 raised to minus 1,
16, that is
minus 2. And then for B, we have 11. So 11 into 16 raised to minus 3. When you add all of them, so you get 31.006591. So which is a decimal representation of the hexa number 1F.01b. Yes?
Yes, ma'am.
Once you finish, I'll move ahead. Okay. Suppose I give you a decimal number 3749. Okay. The previous one was you converted a hexadecimal number into a decimal number. Now suppose I give you a decimal number, you have to convert it into hexadecimal. So how you will do? You will repeatedly divide it by 60.
Divided.
Okay.
Yeah.
So suppose I give you a decimal number 3749. Okay, you have to convert it into hexadecimal. Like for binary, we divide it by 2. For octal, we divide by 8. For hex, you divide it by 16. So 3749, you divide by 16. The quotient, you will be dividing it by 16 and the remainder, you will storing it separately. Now, once quotient is 0, you will write from bottom to top. I think 3 times you might have to divide it. So 3749, you divide by 16. So we divide it by 16 first time. So do this division.
Yes, ma'am.
So we have 217.
Yes,
remainder becomes 7.
Yes.
Then again 217, you divide by 16. Please do it, even though it is there in my slide, you do it. So 217, again I divide it by 16. So the quotient is 13. Remainder is 9. 13, if I try to divide by 16, it doesn't get divided by 16. Okay, so here you write down this step. Here write a 0 over here. Okay, so the remainder then becomes 13. And then I read from bottom to top. Now I cannot write 13. In hex, we don't have 13. We have 0 to 9. What is equivalent of 13 is D. 9, 7 as it is. So it is D9, 7. Okay, so the equivalent hexadecimal number will be D97. So the binary decimal number is 349 and the hex equivalent is D97. Now once you finish, you tell me, we'll go ahead.
Yes, ma'am.
Yeah. Now we will convert a hexadecimal to a binary and then again a binary to a hexadecimal number. So we have the hexa. Now why we go with the hexadecimal number? Because later on when you will study microprocessor, you will see that for a microprocessor, go for a hexadecimal representation. Okay, and this is already, you know, the base of hexadecimal is 16.
16 years, ma'am.
15. So we have the numbers from 0 to 9 and the
15,
alphabets A
yeah.
to F. Okay.
Yes,
Now,
yeah.
why we usually go for hexadecimal numbers is binary numbers is in the form of ones and zeros. Okay. So a big stream of ones and zeros sometimes, like, it occupies more space. So those large numbers, we can easily represent it by a hexadecimal number. Okay, that long streams of ones and zeros, if I write or represent it in terms of hex, the number of bits will be not lengthy compared to a binary. So that's why we prefer, or microprocessor prefers, hexadecimal notation.
Hexadecimal.
Okay, now this already you know. Again, this table, it's written in the horizontal form. So you have the numbers from 0 to 15, the decimal number, the binary, this table already you have drawn. Okay, from 0, 0
Yeah, yeah.
to 1, 1, 1. And so the hex representation is 0 to 9,
Yeah,
and
yeah.
then A,
0 to
B,
9.
C, D, E, and F. So F in microprocessor is 1, 1, 1, 1.
1, 1, 1.
Your decimal number system, it is 15. Okay, so the same thing, we will be using it over here. So suppose I give you a hexadecimal number 9AF, and that I want to convert it into a binary number. Okay, so binary is in all in terms of ones and zeros. So what you do, you write this 9AF little separately. Okay,
Okay, okay, ma'am.
AF. Now what is F from that table? It is 1, 1.
That is 1, 1, 1.
Okay,
1.
A is 10. Okay, so that
10.
is 1, 0, 1, 0. This is 2 and 8. So 8 plus 2 is 10. Okay, and 9 is 1, 0, 0, 1. So each individual letters of the hexadecimal you will take. So for F, it is 1, 1, 1, 1. From this table, you can see it is 1, 1, 1, 1. Okay, then for 8, it is 1, 0, 1, 0, and for 9 it is 1, 0, 0, 1. Okay, so I'll write all these separately, and then what I'll do, I'll remove
Okay.
this space and I'll write it in a continuous string. So 1, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1. So this is the binary equivalent for the hexadecimal number 9AAF. Now remember, it is 4 because hexadecimal, the base is 16. 2 raised to 4 is 16. So for any hexadecimal, there will be 4 bits. Okay, so always remember this, because next topic, it will be binary to hexadecimal. So zaruri nahi hai ki jo last bits hai, it is 4 bits, but you have to add some zeros that we will see and make it a pair of 4. So this 4 together, this 4 together is A, this 4 together is F. Because 2 raised to 4 gives me 16. So that is the base. So there has to be 4 bits. Okay. So if 4 bits are not there, you have to add later on. Yahan to directly 4 bits aa hi jayega. Okay.
Yes.
This is very simple. Hexa is only this table you have to remember. Okay. So this is clear. Hexadecimal to binary.
Yes, ma'am.
You have written this problem?
Yeah, ma'am. Written.
Okay.
Yeah.
Now suppose I give you this number. This you have already seen, 152.25. This is in hexadecimal representation.
Yes.
You convert it into a binary number. So for 1, you write what is the binary representation.
Yes, ma'am.
4 bits should be there. For 5, you know the table is there. For 2, you will write separately. A, you write separately. Then the point you keep as it is. Again for 2 and 5. Here you can see I have written with different color. So 1 k 0, 1. For 5, it is 0, 1, 0, 1. For 2, it is 0, 1, 0. Okay, for A, it is 10. So 1, 0, 1, 0. The point as it is. 2 is again 0, 0, 1, 0. 5 is 0, 1, 0, 1. Okay. And then we write all continuously. So this is your binary representation of the hexadecimal number. So you pick up individual number, digit, and write the binary representation. And then write all continuously. So this becomes the binary string. Now you
Binary.
so many digits or space it is occupying. Okay, now
Yeah.
everywhere we want to have the minimum space because it is occupying that many bits in the memory. Okay, so what we do, microprocessor they uses hexadecimal. Here you can see only 1, 2, 3, 4, 5, 6, and this one point. Was such a big thing. Okay, so
Yeah.
microprocessor goes for hexadecimal representation.
That way. Okay. Yeah. And why this is written some different on your order?
Uh-huh.
Why is it written in different order? Like starting is 001, but here it is
एक
the
मिनट
answer it is
हाँ,
written.
नहीं यहाँ पे ये जो 3 0 है ना वो ही डिस्कार्ड किया है ये देखो 0 गो फ्रॉम हियर दिस पॉइंट 0 1 0
अच्छा
0
from
ये
there.
जो एक्स्ट्रा है हाँ वो हटा दिया है रेस्ट यू कैन सी फ्रॉम हियर इट इज सेम 1 0 1 0 1
Okay. Okay.
0 0 1 0 so because as I have said no we have to make 4 per pair so 1 is 0 0 0 1 okay so that when is actually adding number of zeros it doesn't have any meaning okay
Okay.
extra this is a good
So
question you asked because
yeah, but then we can write it the same. How it is
no
on
but
top.
it will actually better
You have
you
to
write
write.
this representation
That way.
yes
Okay.
because adding zeros it does not have meaning but when you are grouping it यहाँ से start होगा grouping पीछे से 4 then the next 4 then the next 4 so it is understood if one is alone over here आगे सारे zeros होंगे
Zeros. Okay.
it will be only the case when I have one का representation 1 2 2
अच्छा.
3 के लिए भी होगा okay except this MSB for all we can these extra zeros if you write no problem but then you know ki extra zero
Sorry. Okay, ma'am.
good observation shall we go ahead
Yes, ma'am.
okay now a binary to hexadecimal conversion suppose I give you a binary number ye pura ek string diya hua hai what you do from behind you make it a group of 4 4 4 4 and then for that group of 4 you write the hexadecimal equivalent like for 0 1 1 0 you know it is 6 so this is the entire string that is given a binary continuous string continuous string hai when you group it from behind you start from the LSB you make a 4 and for this you write the equivalent hex notation so 1101 is nothing but D in hex 1000 is 8
8 and 1
is E so the equivalent hexadecimal number is E8D6 so you write binary string you can underline 4 bits together and then immediately the hex
6 1 is D. Yes, ma'am.
So for hexadecimal, you have the number, you write individually. For binary, groups of 4 and then you write the hexadecimal representation. So both are very easy.
Yes, ma'am.
Nothing to divide and nothing to multiply in case of binary to hex or hex to binary. Finished with this problem?
Yes, ma'am.
Okay. Now binary to hexadecimal conversion. So what you do, suppose I give you a binary string. As I have said, from this side, you make pairs of 4 bits. Okay, from both the side. यहाँ से भी 4 bits का करना है. यहाँ you will move from left to right. Here you will move from right to left. So I make groups of 4. So यहाँ पे 4 का grouping किया, यहाँ पे 4 का grouping किया. Now you can see there is only 1 1 1. Okay, so what you will do? There should be a 4. So I add 1 0 over here. So this is exactly 4 4 4. Now what is 1 0 1 1? It is B. 1 0 1 0 it is 10. Okay, A. And 0 1 1 1 is 7. 0 0 1 1 is 3. So it is 7 A B 3. So this is the hexadecimal representation of this particular binary string. So this
No, that no, that's right.
one bit over here to make it 4.
Yes, ma'am.
4 bits. Shoot.
No, 2 minutes. I'll just write it.
Once you finish, you tell me.
Yes, ma'am. Yes, ma'am. Hello?
Just a moment.
Yes, yes, ma'am.
Okay, now suppose I have an octal number. I'll convert it to binary and binary to octal. See, we just now we did hexadecimal. Just a moment.
Yes, ma'am. Hexadecimal.
Huh. Hexadecimal to binary and binary to hexadecimal.
Yeah.
So what we did,
Hexadecimal.
that binary string we made groups of 4, 4, 4, and then we wrote the hexadecimal. Now octal is base 8.
8.
So 2 raised to 3 is 8. So we will now make groups of 3.
3.
3, 3, 3, and then we will write the octal representation of those 3 bits. So this already you know, it has a base 8. It contains digit from 0 to 7. So here just remember we are making groups of 3 bits, okay, from the right side of the binary number.
Okay. Yes, ma'am.
So suppose I give you the octal number. This is octal number 35.346. Here you will not find 8 and 9. So 35.346. Again, you write down little, keep a little space.
Yes, 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 ma'am.
Octal point. So 5 3 bits representation. So 101. 3 is 3 here it is wrong. 0 1 1.
0 and 1, 1.
Here you can see 3 is 0 1 1. So यहाँ पे 0 1 1. 4 is 1 0 0. 6 is 1 1 0. Okay, so in decimal number you write the 3-bit representation. So the reduced binary, here the answer is written correct. 0 1 1 101.0 100 110. So write all this continuously. Don't leave a space. This is for your understanding. I've kept a space. It's a continuous strings of ones and zeros. Individual octal number, you write the 3-bit representation. Keep the octal point or binary point, both are the same at the same place, and then write the string.
Yes, ma'am. Yes, ma'am.
Yes?
Yes, ma'am.
So this is how you convert octal to equivalent
Octal to
binary
equivalent
number.
Binary.
Finished?
Yes, ma'am. Yes, ma'am.
Now convert this 152.25, the same problem.
Okay.
Convert it to binary. So for 2, write 3-bit representation. For 5, write 3-bit. For 1, write 3-bit representation. Again, keep the binary point, octal point at the same place. Again, write 2-bit, 2 representation in terms of 3-bit, 5 representation in terms of 3-bit, and the continuous string. So if you see, so for 1, 5, 2 and 5, so if I write it, so here 2 is 0, 1, 0. Here you can see 2.
Got my 0, 0, 1.
Huh.
1,
1, 0,
1,
1.
0, 1.
And then 0, 0, 1.
1, 7.
You might discard this 0 when you want to write the answer. You can keep it, no problem. And then for 2 and 5. So this is your octal to binary.
Binary.
So this is simple.
Yeah.
Same process for hexa and octal. In hexa, we make groups of 4. Here we are making groups of 3. The same one we will write 0, 0, 0, 1 for hexa, and here in octal we will write 0, 0, 1.
Yeah. Yeah. And
now this is, I'm going to convert binary to an octal number. So again, binary, there will be a string given. So suppose I give you this string. Okay, copy this string. So what you will do from the point, your starting point is over here. From this point, you will make groups of 3.
Yes.
Just check if one extra 0 needs to be added or not. If you have exactly groups of 3, leave it. Otherwise, at least one there. So you add the remaining zeros if you feel. Okay.
Yes.
Otherwise, it is one value only. We know the first digit is 1. So it will, whatever bits you add, it will be giving you octal 1 only. But here,
Yes,
I think all were there. 3, 3. Here exactly there were 3 bits pairing. Okay.
Yes.
So for 1, 1, 1, we have 7. For 1, 0, 1, 0, 0, it is 4. No.
4. Yeah, it is 4.
So
yeah,
I will change this point. So here you make it 1. So then it becomes 5. So here just try make 1.
Okay. Okay.
Okay. So then it is 1, 0, 1 is 5 over here. 0, 1, 0 is 2. So the octal representation is 2, 5, 7.
Yes, 2, 5, 7.
3.
1, 4. Yes.
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 Exactly the reverse process here we are doing.
Yes.
Octal to binary, binary to
Yes.
octal.
Yes,
Oh. Now suppose I give you another binary string. Okay. Convert this and see. This is the binary string that is given. Make from this point, make groups of 3, 3, 3. Here also you will make groups of 3. यहाँ पे 1 है, so you will add the remaining 2 zeros over here. This is important. From the decimal point, here we had groups of 3, so 0, 0, 1. Uske baad I had only 1 over here, but I have to make groups of 3. So what I do, I add this 0, 0. See, by adding this 0, 0, the meaning changes. It becomes 4. 0, 0
yes,
is 4.
yes, and the last one is
लास्ट वन यहाँ पे देखो 0, 0, 1 है, उसके बाद नेक्स्ट ग्रुपिंग में सिर्फ 1 इज अलोन. ओके, बट आई नीड 3 बिट्स. So what I do, I add this 2 remaining zeros. So this becomes 4.
Yeah.
2 raised to 0 is 1, 2 raised to 2, 2 raised to 2. So that is third position. So that is 4. So that's why ये है 1, 0, 0, 1 is 1 and 4 is 1, 0, 0. So that's why it is 1 and 4. Don't forget to add this.
Yes, ma'am. Yes, ma'am.
Rest, I think this part does not have any problem. It's all groups of 3, 3, 3, and 3. Yes?
Yeah. That is fine. Yeah.
Huh.
Yes, ma'am. Yeah.
Now, hexadecimal. So we have converted almost everything to decimal.
Yeah. Yes,
From decimal to the other one. Okay, now suppose I give you interconversion between hexadecimal to octal. Now what will you do? What we were doing, either we were dividing it by 16 or 2 or 8,
yeah.
accordingly, or writing in terms of 3-bit representation, 4-bit representation.
Yeah.
But now
Yeah.
from hexadecimal to
Start
octal
off.
or octal to hexadecimal. Now see,
Okay.
what you will do whenever any one of them is given. Now there is, you cannot say 8 or 16 ka kya relation hoga, nothing like that. So what you will do is, but binary is something which is common to both, because binary also has only representation in terms of ones and zeros. So whatever is given to you, either hexadecimal to octal or octal to hexadecimal, what you will do is you will first convert the hexadecimal to binary. Okay. फिर
Okay. Okay.
हमारे पास strings of ones and
Yeah.
zeros ही
Then
रहेगा.
so.
And then we want octal. So what you will do, you will make groups of 3. Yes. And then you write the octal representation.
Yes, ma'am.
Similarly, if I'm
Octal
given
number.
an octal representation, the very first step is you will write the binary equivalent. Okay, so once you convert it into binary equivalent, you get strings of ones and zeros.
Things are
Then
ones
what you
and
do to
zeros.
convert it to
That
hexadecimal, you will write or make groups of 4 bits
four.
on the side of binary point, and you will write the hex equivalent of those 4 bits. So this is how you will proceed.
Sample.
See with an
Yeah.
example.
Hello. Hello.
Okay, so suppose
Hello.
I give you 152A.25. It is in hexadecimal notation. I want to convert it to an octal representation. So what you will do is, this string is in hex, so you will write the 4-bit representation of that hex number. So A, 2, then this is 5, this is 1 in terms of 4 bits. Similarly,
Yes, ma'am.
00105 hai
0.
0101. So this is the
0, 1, 0,
entire
0.
strings of ones and zeros.
Yes, ma'am.
Now what
Ones
you
and
will do
zeros.
is you will
Got it.
make pair of 3 bits with this number. Okay, so this particular number you are making pair of 3 bits. So from your 3, again 3, and which if it is less, remember to add 0. Here I
0. Yeah.
1 2 3 1 2 3 यहाँ पे 2 ही था 0 1 था, so you added 1 0 over here.
Physics 0.
Similarly, groups of 3, यहाँ पे 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 3. Okay. And then the 0 was there, 0 has no value alone. Okay. So then you write the octal representation. So this was 0 0 1. So this is 1. The next number was 0 1, so it is 1, and this was 0 1 0, so that is 2. From here if I go 3-bit representation, 0 1 0, so that is 2. फिर क्या है 0 1. Do this carefully. 1 0 1 वो है 5.
Confusing.
It will be confusing, so you leave space. हाँ properly वो underline करके अच्छे से करो. Do it nicely. Yes. Because once you have this whole string, make group, draw line. यहाँ line draw करो, एक ऊपर करो, एक नीचे करो, line draw करो.
Yes, ma'am.
Okay, so octal representation is there. The very first step, convert it into binary. So that 3-bit binary representation for this. For hex, you again make pair of 4 bits on both the side of the binary or the octal point. If it is not exactly 4 bits, you will add zeros on extreme sides. Sides mean on this side also.
So 0 का है 0.
So this, when you are writing, we are discarding because it is आगे 0 डालने से कोई फायदा नहीं रहता. So this is 6. This is 10.
Yeah.
10 in, now see, remember it is hexadecimal representation.
Yeah,
so
this is
10 is A.
A. 10
And
is A.
this is 5. 0, 1, 0, 1 is 5. 0, 1, 0, 0 is 4. So 6A 0.54 is the
6A 0.54.
6A.54 is the hexadecimal representation of the octal number. So octal to hexadecimal, remember you will first convert it into binary, that is strings.
Binary. Yes, ma'am.
Okay. For either octal or hexadecimal, jisme bhi you want the conversion. For octal, you will make groups of 3. For hexa, you will make groups of 4 bits. Okay. And if 4 is not there proper or 3 is not there proper, you will add those.
You add zeros.
On this side आगे ऐड करोगे, ये आगे है MSB में, और यहाँ पे पीछे ऐड करोगे LSB में. Okay. Because see, आगे ऐड किया तो as such it is not affected, only that grouping is there. But यहाँ पीछे अगर ऐड नहीं किया तो you will feel 0, 1 is 1, but you after adding this 2 zeros. So this is important.
Yes.
Yes.
Yes, madam.
So now with this number conversion is complete in the first chapter. Okay. We have the ones complements and twos complement that I'll take tomorrow. So I will give you right now, just now I'll send you on WhatsApp